Welcome to LNP Renewable Limited. Today we are going to discuss some of the MEP Basics Part 9. If you have missed Part 1 to 8, please subscribe to our channel. In our channel we had created a playlist MEP Basics Part 1 to 12 English, so that whatever thing that you have missed in the discussion related to mechanical, electrical and plumbing basics, you can refer to that. So in our discussions we might be using so many symbols, acronyms and short forms. So if you have any sort of doubts when listening to the video, kindly please refer to this part so that it will give a clarity to you regarding the acronyms that we have referred in our discussions. So what are the things that we are going to discuss in the part 9 today? How a single zone air handler with a dual set point thermostat looks like, and what is the relationship between a supply air, return air, exhaust air, okay, recirculation air, outdoor humidity, okay, what is the relationship between them, okay, how a primary and secondary pump system of a chiller looks like, okay, how a heat recovery system in a closed loop looks like, we are going to see. So this is a typical single zone air handling unit. As you can see here, this is the duct, okay, this is the duct. So we have a temperature sensor to measure the temperature, okay, and we have the chill water supply line and hot water supply line. So for the chill water supply line, in the return line we have installed a valve actuator. So we have a valve, we are controlling the valve using the valve actuator, okay, and also in the same way for the hot water supply also we are controlling on the return line. We have installed a valve, we are controlling the valve using the valve actuator, okay. We have a interlocks for the fans as well in different places. We have a duct smoke detector. This is a motor, main motor starter, okay. So this is how typically a simple single zone air handler looks like, okay. Next, if you have a single zone unit with a dual set point thermostat, as you can see here, we have a 2 set point thermostats. So apart from it, rest of the things are same, okay. We have a fan, we have the fan to start, we have a motor starter for the fan to run, supply fan to run especially, and the same way for the chill water supply line control, especially on the return line, we have installed a valve as well as a valve actuator to control it, and the same way for the hot water also, in the return line we have installed a valve with a valve actuator. As you can see here, why we are using the 2 thermostat, because for the heating process to happen we need a set point, okay, and in the same way for the cooling process to happen, in order to control the chill water actuator we need a set point. In the same way, in order to control the hot water supply, especially hot water coil supply, okay, hot water in the coil supply, we need a set point. So for that one we are using this dual thermostat. These are olden methods. Nowadays it has been advanced, but we should know the olden methods, because what are the equipments that we are using there, still we are using it. Only thing is that the advancement is made on the controllers. So as you can see, this is a schematic which is showing the relationship between the supply fan, return fan, and most importantly that is EA, exhaust fan, okay. So if you are considering a building space, okay, it has exfiltration as well. You are supplying that building with the supply fan, and you are taking away the air from that using the return air also. So if you want to calculate the total supply air, it is a combination of, okay, outdoor air intake plus, okay, plus return air minus outdoor air relief. So return air minus outdoor air relief plus outdoor air will be equal to the supply air, okay. In the same way, if you want to calculate the inside the building space, especially the supply air, we need to know the return air plus most importantly EX here refers to the exfiltration plus most importantly exhaust air. So if we add all these things, we will get the supply air inside that building space. So this is a simple relationship between the supply air, return air, and most importantly the exhaust air. So most importantly, normally, you know, in all the big places where we are using the chillers, we used to have 2 chillers, because if one chiller is working or if it fails, okay, we need to have a standby for it. Then in such cases we can go for the second chiller, or else sometimes demand might be more, okay. One chiller is not sufficient to satisfy the low demand of the air handling units or VAVs, especially in the building. So in such occasions we will go for the 2 chill water valve actuators, 2 chillers, and most importantly once the cooling water is getting chilled inside the chillers, it is getting pumped to the buildings with the help of it is getting pumped to the distribution side with the help of the chiller pumps. After that, using the distribution pumps, it is being fed to the buildings, to the loads. Okay, and in all the locations we will have a pump. Most importantly, we will have a valve control to control the flow of water inside the pipelines. Okay, and most importantly, even for the distribution side also, we will have a primary as well as a secondary pumps. Okay, so here the chiller pumps are playing a role as a primary, whereas on the distribution pumps are playing a role as a secondary pumps. Okay, and even in between them also they will have a primary and secondary. And if you are going for any sort of heat exchanging process, there we also have a primary side as well as the secondary side. See, this is the best example we had given. So as you can see, from the chillers already we are getting the chill water. Okay, it is from some other different location we are feeding through the supply line. As you can see here, we have a heat exchanger, and this is the water which is coming from the building. So what is happening? A heat exchange process is happening between the heat exchangers. Okay, this is the primary side of the heat exchanger, and this is the secondary side of the heat exchanger, and these are the distribution pumps inside the building. Already these pumps, this water is coming from some other place using the chiller pumps. Okay, they pump the water from there to our concerned destination, concerned location. Okay, as you can see here, we have so many sensors to measure. Okay, we have so many temperature sensor, pressure sensor. Okay, temperature transmitters, pressure transmitters, and flow transmitters. Most importantly, to measure the flow as well as, and also in order to know the healthiness of the pumps also, we are having a differential pressure switches also. So this is a simple video which explains you how this is the heater. It is sending away the hot air to the environment. Okay, say for example, it is around 32 degree, it is stepping down to 27 degree. Again, with the help of the chillers, it is getting cooled to 16 to 18 degree. So this is a simple chill water is being supplied inside a building, and these are the air handling units. We are consuming the chill waters in order to cool the concerned buildings. As you can see here, in a closed loop, we have a supply line. So there will be a separate piping for the supply, and there will be a separate piping for the return lines. We will be using so many pumps to pump the water from one location to the other locations. Okay, as you can see, we have a cooling towers also. Okay, so this is a typical overview of how a supply pipeline and the return pipeline looks like. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, you can contact us. We have provided the contact list here. We, LNP Renewable System Leader, we are providing PLC programming training for Siemens, Allen Bradley and Delta PLCs. And most importantly, if you are really interested to work in GCC countries like Qatar, Oman, Saudi, especially in building management system, building automation control system, if you want to know the electric vehicle basics, access control system basics, then you can contact us. We are providing training on it. And if the EV power is not available, if you want to establish a solar DC light system in such occasions, such places, you can contact us. And most importantly, you might have agricultural farms. If you want to protect your crops from the wild animals, instead of going for normal fencing, you can use solar electrical fencing. We are providing solar fencing as a kit. We are also providing solar on-grid, off-grid, hybrid application, solar street light, solar pump services, design, installation, testing and commissioning, consultancy, training supports. Thank you so much.